Neisseria gonorrhoeae features. It is gram-negative in nature. It is non-sporulating, non-motile bacteria, which is a cocci, and it is oxidase positive in nature. The most important human pathogens of Neisseria group are Neisseria meningitidis and Neisseria gonorrhoeae. It is very important and fastidious in growth requirements. The intracellular presence of these bacteria inside the polymorph in the patient is a very important characteristic. That is the first characteristic. Coming to the second characteristic, that is its capsule. And the capsule is made up of a polysaccharide even in case of Neisseria meningitidis, and the presence of plasmids, including those which can impart antibiotic resistance to Neisseria gonorrhoeae, is one of the important characteristic of N. gonorrhoeae, and the important characteristic of N. meningitidis is the presence of a polysaccharide capsule. Coming to the some other species of the same genus, that is N. lactamica, which is present as a common commensal in mouth as well as in the respiratory tract, while Moraxilla cataralis is commonly involved in respiratory tract infections. Neisseria meningitidis has a very pathogenic disease which is called as the meningococcal meningitis, also called as cerebrospinal fever. This can be sometimes sporadic, or sometimes it can cause epidemics, or sometimes even localized outbreaks, and even septicemia can be caused by N. meningitis. Now, going with the Neisseria meningitidis morphology, it is a very small bacteria, approximately 0.6 to 0.8 micrometer in size. It usually occurs in pairs, that's why it is called as a diplococcus, and its adjacent sites are flattened. Coming to the cultural characteristics, these essentially require an enriched media because these are fastidious organisms, and their function and the function of this enriched media is not to provide additional nutrition, but it is actually to neutralize the inhibiting substances that are present in the cultural media. Coming to the growth factors that it requires, it is capnophilic, so it requires 5 to 10% carbon dioxide and high humidity. It requires 35 to 36 degrees Celsius, that is normal temperature, to grow, and a pH of 7.4 to 7.6. Solid media, it grows usually on either solid media or liquid media. So in solid media, the colonies will be usually small. These will be translucent colonies which will be round and convex and bluish gray. Coming to blood agar, in blood agar, the colonies are typically lenticular in shape, unlike the round shape in case of the solid media, and they will be butyrous in consistency, and they are easily emulsifiable. On blood agar, a very important characteristic is that it can undergo a small amount of hemolysis, that is, a weak hemolysis can be shown on blood agar. In liquid media, these colonies are not lenticular, but these are smooth and rough type of colonies are formed in case of liquid media, and they produce a uniform granular turbidity with little or no surface growth at all. So the basic very important cultural media which we need to grow the Neisseria is blood agar, chocolate agar, Mueller-Hinton starch casein hydrolysate agar, or modified Thayer-Martin agar, which contains vancomycin, colistin, and nystatin. Coming to the biochemical reactions, this Neisseria is catalase and oxidase positive. The prompt oxidase reaction helps in identifying the Neisseria in mixed culture. So therefore, oxidase reaction is a very characteristic reaction to differentiate it from other bacteria. So let's study in detail about the oxidase test. So the oxidase test involves using freshly prepared 1% solution of oxidase reagent. What is this oxidase reagent? It is tetramethyl paraphenylene diamine hydrochloride, which is poured on the culture media. As a result of which, if the culture media turns deep purple, then it shows a positive test. But you cannot expose the oxidase reagent for a long time to the same culture media, because the organism might die on prolonged exposure to the reagent. So we need to perform subculture should be grown immediately after adding the oxidase reagent. Alternatively, you can use another test, that is by the COVAX method can be used to perform this oxidase test, and deep purple color turning immediately indicates a positive test. Coming to indole and high TSI reaction, that is in TSI reaction, it can only utilize glucose and maltose, but never does it utilize sucrose or lactose. Thus it produces acid, but no production of gas takes place. And remember that acid is produced not due to maltose, but the acid is produced due to the glucose. And this can also be tested on peptone serum agar slopes containing sugar and indicator. Coming to the antigenic properties and the classification of Neisseria. Now the first is about the serogroups. The serogroups, all of them are capsulated, and there are very importantly, they have been classified into 13 serogroups, out of which 6 are the most common ones, while 7 are not so much common. The 6 common ones are A, B, C, X, Y and W, or you can say A, B, C, W, X, Y. In W, it is W135 strain is present, and the group A is commonly associated with epidemics. A is associated with epidemics E, and group C is associated with outbreaks, while group B is present both with epidemics as well as with outbreaks. And coming to the group 29E and W 135 and Y, these are most commonly involved in meningitis. Coming to resistance, these are very delicate organism. How much delicate? That is, they can become even susceptible to heat, desiccation, alteration in pH, or to disinfectants also. And they were uniformly sensitive to penicillin and other antibiotics before, but now we can even find resistant strains also.